All right. Addition equations, we do the inverse operation. We do that additive inverse. And so this is not going to be anything different. When we have multiplication equations, we're going to be doing multiplicative inverses. So the whole goal of that was to get to that identity property, which was going to allow us to find our variable. So let's go ahead and review some of our inverse operations when it comes to multiplication, because we did some slightly different things with them. So what is the inverse operation of multiplication? Don't tell me division. Lola. Multiplying by the reciprocal. So we are multiplying by the reciprocal. And what about multiplying by a fraction? Is it anything different if we're multiplying by a fraction? Is it any different? Kip yes or kip no, is it any different? No, it's not. So we're going to write the same thing. Now when we had division, we did something that was slightly different. We talked about inverse operations of division. We did something slightly different. We didn't have a divisitive inverse or anything like that. We said, hey, we're going to take divisions, and what are we going to do with those divisions? What did we do with those divisions? Is we rewrote So we're going to rewrite the division as multiplication of a fraction. And then once it's multiplication of a fraction, then what can we do? Once it's multiplication of a fraction, what's our inverse operation there? Dahlia? Multiply by the reciprocal. So that makes it really easy. Alright, so let's solve some basics. So here we have 2.5 times x is equal to 15. So I have 2.5 times x. What is my multiplicative inverse for a multiplication of 2.5? There's only one answer pretty much all day long today. What is my inverse operation? Jaquan. What is our multiplicative inverse for multiplication? Sammy. Okay, so we're going to multiply by the reciprocal. We're trying to get that identity property that's going to leave us with just a multiplication times x. So I need to change this into a fraction. 2.5 over 1. And I'm going to multiply by the reciprocal. 1 over 2.5. And if I do something to one side of the equation, you must do it to the other. So I'm going to multiply by 1 over 2.5 over here. Commonly, people want to multiply by 1 over 2.5x. Here's the problem. If we do that, all of our x's will end up canceling out because we get 2.5x over 2.5x, which would mean that was 1. Are we trying to find the value of 1? No, we're trying to find the value of x, so that would be bad. That x should not be there. So if you wrote all that down, now you got to erase it. All right. So we have this 1 over 2.5, and the reason why this works, and we're going to prove that this works, is this next step. A lot of people are going to leave this step out when they start to do their work today, and I'm going to get really frustrated because then the only thing that you're learning today is this very mechanical, memorized process. First I do this, then I do this, then I do this. This is the piece that makes sure that you understand that it's more than just a single process. I can put more equations in front of you and you'll know exactly what to do. So here we know top times top would be 1 times 2.5, so that's 2.5. Bottom times bottom would be 2.5. Why is that so important? What does that tell us? Adrian? Yeah, that's a value of 1, and 1 times any number is? 1 times any number is the same number. So this is our identity property. So remember, we're always looking to do an inverse operation that's going to lead us to our identity. And in this particular case, we're looking for the identity of x. So we've got the identity times x. And that's your goal. Anytime you're doing inverse operations to solve an equation, you're just looking to try to do an operation that's going to give you the identity. All right, so now that we see that identity, we know that using the identity property, this is going to be x, and 15 over 2.5, we'll have to do the division. Decimal moves in here, decimal moves here. 25 goes into 156 times exactly. Decimals up straight. So we're going to get x is equal to 6. So let's do that again over here on the right-hand side. We've got a very similar problem. What's my inverse operation? I have a multiplication. What's my inverse operation? Preston. Yeah, so multiply by the reciprocal. He's turning this into a fraction, and he's going to multiply by the reciprocal. So we'll do that on a separate line. 0.5 over 1 times x is, and our inverse operation to multiply by 1 over 0.5. This is negative 15 over 1. We're going to multiply by the same thing on the other side of the equation. And here, our proof that this works, and our proof that this is indeed getting us to the identity of x. I multiply top times top. Gives me 0.5, bottom times bottom, gives me 0.5. And there's our identity. 0.5 over 0.5, that's 1 times x. That's going to give us x. On the other side, we have top times top is negative 15 over bottom times bottom is 0.5. So we're going to get a negative answer here. Do this division. Move the decimal 1 time, move the decimal 1 time. 5 goes into 15 3 times with no remainder. Does that mean the answer here is 3? No, because we've still got one more place value to fill in here. So those of you who are really not very neat with your long division run into issues with problems like this one because we see that there's an open place value that we need to fill. Is my answer 30? Callie, why no?
Because it's negative 30.
Yeah, it should be negative 30. Good catch. And that's one of the small things. We need to be focused in on those details because these problems are not particularly complicated, but it adds ideas from fractions and decimals and positive and negative values that we just have to keep more careful attention. All right. Now we run into another problem that's a little bit different. This one says b divided by 3 is equal to 15. Now we have b divided by 3. What did we say we were going to do for inverse operations when we had division? We wrote it down, so you should be able to read it. Jaquan.
Write division of multiplication of a fraction.
Yeah, we're going to rewrite this division as multiplication of a fraction. So all I'm really going to do here is I'm going to say, well, I wanted this to be b over 3, which would be the same thing as b times 1/3. Kip yes or kip no. I understand how to write a division as a multiplication of a fraction. Kip yes or kip no. I understand how to write a division as a multiplication of a fraction. Seeing a couple of no's. So let's look over here and let's have another couple of examples. So I have h over 4. How can I rewrite that as a fraction? Jesus. 1 over 4 times h. And the reason why that is that way is because if we put that h over 1 and did top times top and bottom times bottom, we'd end up with h over 4. So it's kind of just factoring. We kind of talked about this in the previous unit. Let's do another example. I have n over 5. How do I rewrite that as a multiplication of a fraction? Sammy. 1 over 5 times n. Now I'm going to give you one that's a little bit more complicated. 2n over 3. How can I rewrite that as a multiplication of a fraction? Brandon, what do you think? Sorry, can't hear you. So I have 1 over 3 times 2n, but can I go ahead and break out that 2 as well? So I can just slide this multiplication of 2 over here onto my fraction. Same idea. All right. Okay. Back over here. So now we rewrote this as a multiplication of a fraction, so this becomes very obvious to me. What is my inverse operation? We have a multiplication, so the inverse operation, Dahlia? Multiply by the reciprocal, where our fraction is 1/3, so the reciprocal is 3 over 1. So here we have top times top, that's going to give me 3. Bottom times bottom, that's going to give me 3. Top times top is going to give me 45. Bottom times bottom is going to give me 1. Well, that 3 over 3, that's our identity property. That's what we were trying to get to. The identity of b is equal to 45. Slide over to the one next to it that's almost exactly like it. I have r over 3.2. How do I rewrite this as multiplication of a fraction? Jasmine. Yep, so we'll mark this out and we'll make it 1 over 3.2 times r. So Aaliyah, what is my inverse operation? Yeah, with reciprocal. So I'm going to multiply by 3.2 over 1 times my 1.32 times r. If I did that to one side of the equation, I need to do it to the other. So I'm multiplying by my 3.2 over 1 again. Over on the left-hand side, I do my top times top and bottom times bottom. That's going to give me 3.2 over 3.2. Once again, that's that's multiplicative identity. That's why we know that that times r is going to be equal to r. Simplifying over on the right-hand side, negative 5 times 3.2 is going to give me negative 16 over 1, which is negative 16. Questions about that? Jasmine. Multiplying by our reciprocal in this blank over here would give us 3 over 2, which means that on the other side we need to do the exact same thing. Oops. Which is multiply by 3 over 2. Give that a fraction there. So top times top, bottom times bottom is going to give me 6 over 6. Top times top and bottom times bottom is going to give me negative 18 over 2. And so thinking about the multiplicative identity, 6 over 6, that's just a multiplication of 1. And that's going to give me b is equal to negative 18 over 2 is negative 9. So as we come over here, the only thing that's a little bit different about this one is we've got a negative 5/3. That means we just need to put that negative somewhere. We either need to put it on the top or we need to put it on the bottom. We can't put it in both places because then that would suddenly make it a good date, which would make it positive. So what are we going to multiply by? What is going to be our inverse operation here? Aliyah G. 3 over 5. Negative 3 over 5. And that's really important because if we don't multiply by that negative, then what we end up with is something down here that's 15 over, or like negative 15 over 15, which is negative 1. Okay, so the identity property does not say anything times negative 1 is itself. So it would have to be something that is a positive. So here we have it, the way she has set it up, is a negative 3 times a negative 5 would give us a positive 15. Over a positive 5 times a positive 3 gives us a positive 15. So if we multiply by negative 3 over 5 on one side, I need to do the same thing on the other. And I can start simplifying this as well. Negative times a negative gives me a positive 15 over 5. Identity property tells me this is just r is equal to 3. Are there any questions about that? Aaliyah. Why did I not cross cancel?
Yeah.
I could have. I just didn't. Jaquan? So we multiplied both sides by a negative. So I got a negative times a negative, which is a positive. All right, looking at this next one. What is my inverse operation for this one? Callie. Adding a positive 3.9 to both sides. Good. I didn't catch Callie off guard. This is not a multiplication problem, which is why we aren't doing a multiplicative inverse. We're doing an additive inverse. So I'm adding a positive 3.9 to both sides. That gives me b plus 0 is equal to 5.4. So b is equal to 5.4. So this is like one of the problems from yesterday. I'm just throwing it in there to make sure that you're paying attention. Actually, we've got another one very similar to it over here. Juan, what is my inverse operation for this problem?
Add positive 3.4 5.
So we'll add a positive 3.4 to both sides of the equation. And we'll prove to ourselves that the reason why that works is because this negative 3.4 and this positive 3.4 add up to 0, so we get y plus 0. That's that identity that we're always checking for. Do not leave out that step of work. And then we have negative 5 and positive 3.4. So the negative 5 has more absolute values, so we're going to be with negative. 5.0 minus 3.4, because we've got opposite signs, is going to give me 1.6. So we get y is equal to negative 1.6. Questions about that? All right, one more set. Oh, no more sets. I'm out of sets. That's it. All right.